So this is a video about a question about number patterns and how to set it out for the IB MYP exam. Okay, so the pattern goes, an L-shaped pattern is made from dots as shown. Number 1, L1 has 4 dots, and you can see 1, 2, 3, 4 red dots there. Each pattern is made by surrounding the previous pattern with dots. So there's green dots all around the red dots now for the second L shape, and that makes 18 dots, which are a mixture of red dots and green dots. I've surrounded that shape by some more dots to get L number 3, and L3 has 40 dots. You can count them up if you like. So the question is, continue the pattern in the table below. Write down in words any patterns that you observe. Find a general rule connecting L and N. So L is the number of dots in the L shape. N is just the number in the sequence. So the first one is 1, the second one is 2, the third one is 3, and so on. Test your rule, verify your rule, prove your rule, or sometimes it says prove and justify your rule. Okay, so the easiest thing, continuing the pattern in the table. So if we surround that one with dots, we can see that we get 70 dots in total. So that's the ones that were already there plus the new ones. And then if we add another level of dots, I've made them yellow, we get, well, you can pause the video and count them if you like, 108. And then the last one, which I've made blue. So if you add those in, you get, pause the video and count them if you like, 154. So we've earned a couple of marks just for filling in some gaps without really having to do too much mathematical thinking. And it says, write down in words any patterns that you observe. So one pattern that you could easily observe is that the L numbers are always even. Now when they say in words, it's important that it genuinely is a pattern in words rather than an algebra kind of rule. So if you just say, I notice that you multiply the n numbers by something and subtract something else, then all you're really doing is giving an algebraic rule but saying it in words. And that's not the same as well, that's not what they're trying to ask you to do in these questions. So another possibility for that is to look at the differences between the terms. There's often something very revealing in the differences between the terms. So to get from 4 to 18, you've got to add 14. To get from 18 to 40, you've got to add 22. And it goes add 30, add 38, add 46. And you might notice that those differences are 8 more every time. So you can look at something called the second differences. To get from 14 to 22, it's plus 8. To get from 22 to 30, it's plus 8. And it's always plus 8 more every time. So that's a pattern that you can observe. You just got the challenge of trying to express that articulately. So I've said the L numbers always increase by 8 more than before. But another way you can say that is to use better terminology. The second difference between the L terms is always 8. And I've seen mark schemes that reward that kind of terminology. Okay, so that's words, and now find a general rule connecting L and N. So looking at that pattern, it might not be immediately obvious what the rule is, and you kind of need to break down the geometry of it. So the first one, it's like a rectangle, but it's just got a couple of dots missing, and the base of that rectangle is 2, and the height of that rectangle is 3. So it's 2 times 3, but then minus 2 missing dots. So the base is 2, the height is 3, the number of dots is 2 times 3, 2 times 3, minus 2 missing. So if you can get kind of underneath the problem and figure out what's going on, you can start to break it down into easier patterns. So the next one you get, it's like a rectangle, but there's a couple of things missing. It's got a base of 4 and a height of 5. So the number of dots is 4 times 5, but then minus 2 missing ones. Base 4, height 5, dots, 4 times 5, minus 2 missing ones. And then you can start to see the pattern there. The number of dots when you add in another level, it's base of 6 times the height of 7, minus 2 missing ones. Base 6, height 7, number of dots is 6 times 7, minus 2. Now that's not just happening randomly. So you notice that the base numbers are going 2, 4, 6, and you can predict the next one will be 8. And that's happening because we're adding a column of dots that side and a column of dots that side. So we're adding 2 dots to the base each time. And then the same with the height. It started at 3. It's going 3, 5, 7. So you can predict the next one would be 9. And it's increasing in 2s because you're adding a row at the top and a row at the bottom. So the number of dots in total is 6 times 7 minus the 2 missing ones. And you can start to see a pattern for it. So the bases are going 2, 4, 6, 8, 10. So because they're going up in 2s, you can expect that there'll be a 2n in the rule. And then the heights are just going 3, 5, 7, so also up by 2 every time. So you can expect there to be a 2n in that rule. The next one, 8 times 9 minus 2. So you can see it's going 2, 4, 6, 8. There's a pattern to that. The pattern is that the base is always 2n. The height, you can see the pattern to that. It's going 3, 5, 7, 9. So that's an easy pattern to work out, 2n plus 1. So the number of dots, it's the base, 2n, times the height, 2n plus 1. But then minus 2 because of the 2 missing dots. So as I say, if you can kind of break it down into smaller patterns and understand what's going on geometrically, then you've got a good chance of figuring out a general pattern. And often in these types of questions, they do give you some kind of a geometric thing, dots and triangles, so you can visualize what's going on. So that's my rule. L equals 2n times 2n plus 1 minus 2. I could multiply that out to 4n squared plus 2n minus 2, but there's no need to do that because on the mark schemes for these, it'll say accept this rule or an equivalent rule. You see the letters OE standing for or equivalent on mark schemes. And in fact, it's a little bit tidier with the brackets and the factorization there. So that's perfectly good. Okay, then it says test your rule. So to test your rule in these IB questions means to take a couple of the values that they gave you, so they gave you the lower values in the table, and to check that your rule works for it. So for example, when n equals 2, my rule says that L equals 2n brackets 2n plus 1 minus 2. So when n equals 2, if I put 2 in for that, I get 4 times 4 plus 1 minus 2, which is 18. And that matches the value in the table. So I want to make the comment, this matches the value in the table. So when you do this, I want a nice clear heading when n equals something. My rule says put the number in, get the answer out, and make the observation that it matches the value in the table. There is very often a mark for that in the mark scheme, just for that comment, and it's a very silly mark to lose because it's a very easy thing to do. So once again, I'm going to do it for when n equals 3. So a nice clear heading, when n equals 3. My rule says that put the number in, that'll be a mark just for putting the number in. Get the right answer, that'll be one answer for the mark if it's right. And then it'll usually be one mark for the comment, this matches the value in the table. So that's testing. And then when it says verify your rule, that's doing exactly the same thing, but just a bit further up the table, checking that it still works for the numbers that you filled in when you continued the pattern. So when n equals 5, clear heading, my rule says that stick in the number, 1 mark, 5 in this case, so 2 times 5 is 10, and you get 108 out. This matches the value in the table. So good clear communication all round. Clear heading, the formula, the number stuck in, the right answer, the comment that it matches the value in the table. And finally, let's say one more, when n equals 6. My rule says this, I get 154 out, this matches the value in the table. So that's verifying. Sometimes, well, usually they say prove or justify your rule. Now, in my opinion, this is a very hard mark to get for the time it takes. It's not really worth the marks you get for it. So, it might be up to 4 marks, but it might take you, well, certainly it'll take you more than 4 minutes worth of time, based on the average number of marks you're trying to get per minute. But here's how I approached it. So I said the pattern is always a rectangle with 2 dots missing. The width of the rectangle always increases by 2. This is because we add extra columns of dots to the left and to the right each time. Column there each time. And the pattern for the width is width equals 2n. The height of the rectangle always increases by 2. This is because we add extra rows of dots above and below each time. The pattern for the height is height equals 2n plus 1. We multiply these to get the area in dots. That should say to get the area in dots. But we need to subtract 2 because of the 2 missing dots. Hence the rule is L equals 2n, brackets 2n plus 1 minus 2. So what proving and justifying needs to involve is a more general argument. So not just specific examples that work. Putting in 1, it works for 1. Putting in 2, it works for 2. Putting in 5 and 6, and it works for 5 and 6. That demonstrates that the rule appears to work, so it tests it and it verifies it. But to prove or justify it is to make a more general algebraic argument involving the ends rather than specific examples of it working. And as I said, in my opinion, the effort it takes you to do that would be better spent trying to pick up easier marks elsewhere.